Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson. Fred, what are we talking about today?
Well, I thought we mentioned this when we first started chatting, and then we talked about all kinds of other stuff. So this may come back to surprise you, So, so as you know, you and I have talked about it for years, and Carl and I have been working on writing a book. And this morning, we finally sent it off. As we're recording this morning, we've sent it off to an editor to do the burn and slashing work that they do to change every sentence into something that's actually legible and readable and stuff like that. I did actually get one sentence through the editing process once for this editor I really respect, really does improve my writing. But I actually got one sentence untouched years ago, and I was so proud.
Don't believe you.
Yeah.
It's never happened in the history of authorship.
So I don't know if he just kind of overlooked it, or I actually sent the paragraph back to him and says, "Did you miss the sentence? You didn't touch this one." And he goes, "Oh, that one was just fine." It's like, "Oh, cool. Celebrate." Hey. But anyway, it's in that process right now. And so this morning I'm kind of sitting back going, all right, we've done the damage that we could do. Carl and I have written what we're going to write, and we think it's pretty darn close. And we have to do a shout out to all the people and there's been over 500 people that have signed on to take a look at the draft. And most of those people have added comments and feedback and suggestions and stuff. And it's just made the book so much better. But I sat down this morning after kind of getting to this milestone and said, just reflecting on when Carl and I first started talking about putting a book together, is one of the things we noticed, and I don't know if you noticed this, Chris, and I know that you've written a book that's got like a compilation of every reliability method known to man kind of thing, and all kinds of cool stuff in it. But I didn't detect in your work, or in Iris and Coombs and Moss, the Handbook of Reliability Engineering Management, or in Practical Reliability Engineering by O'Connor and Kleiner, how do you put it all together? How do you pick which tools and techniques and stuff to actually use at a particular moment? And it dawned on me that it's part that you need to know what all those things are, just to have awareness of there's something different than a hammer in your toolbox. You can use a screwdriver sometimes. And look, there's multiple types of screwdrivers depending on what task you have at hand. Being aware of the technical stuff, being competent with those various tools and methods is a start to becoming a good reliability engineer and to put a good plan together. But there's something else that was missing, and that is that we have to be able to communicate. We have to be able to actually talk to other people, to influence decisions, to communicate a direction or a vision or what's in it for them. All of those types of things. We have to be able to write and listen and questions and present and facilitate all of these different skills that aren't in any of the other handbooks that I know that are out there. And so that became a core piece of writing this book. Was it's not something you do over on the cubicle of the fourth from the left all by yourself. This process of reliability engineering is really working with other people all the time. And so that was my revelation this morning, and wish I would have thought of that when I started writing the book, but it reflects what Carl and I first started chatting about, was early on.
Well, I think there's two parts of what you just said. And the first part is, which tool do I use? And the second part is, what are the additional skills that I need to have in order to be a master of each tool? So it's all well, everyone knows how to use a screwdriver, for example. Everyone knows how to can look at a YouTube video and work out how to use a bandsaw, at least theoretically. But there's a big difference between you cutting a piece of wood on a bandsaw for the first time versus how a master furniture builder person, whatever you call those people,
Woodworker,
woodworker, what they do, it's the same tool, it's the same wood, but they're masters at it. And so their piece of wood's going to look just fundamentally different to the shards and kindling you produce the first time you decide to.
Oh, you've seen some of my woodworking then.
But the first part is working which tool to use, and the second part is how do you become a master of each tool versus knowing how a tool works.
Mm-hmm.
So, I mean, you talked about Carl Walther. I mean, it's all well and good knowing what a familiar is, but Carl spent much of his career, I shouldn't say most of his career, but much of his career focusing on how to actually make a familiar work, how to use a familiar. You can describe a familiar, but you might be the best facilitator.
Right.
So once you got the right tool, though, then it becomes a mastery. Going back to the right tool, though, I often find that when clients of mine or people who I'm speaking to say, well, which tool do I use? More often than not, they're missing something at the higher level, which is along the lines of what is your organization trying to achieve? What does success look like?
Mm-hmm.
And often they have a blank stare because they haven't thought about that. They say meaningless things. I want it to be safe and reliability, which meets industry standards.
Yeah, we have to do reliability. We were told we have to do reliability here, so we got to do something. And so
right.
Okay.
So going back to the furniture woodworker analogy, are you trying to build a cabinet, a table, a ladder, a workbench? Because until you've answered the question, what does success look like? What are we trying to do? How do you know which tool to use? It's based on what the high level answer to that question is.
Mm-hmm.
The second thing is, well, okay, now we're trying to build a cabinet, or we're trying to build a table. We're trying to build whatever it is we're trying to build. How do I become good at using the 4 or 5 tools I need to use to make my cabinet? And I think a lot of reliability engineering is sort of analogous to, okay, here is a workshop full of tools. Read the user manual for each tool, and now you're qualified to build a cabinet.
Right. No,
that doesn't quite work like that.
No, there's. It reminds me of I'm trying to think if it's Epicurious or there's some website that I frequent that has recipes in it. I've got some set of ingredients, and I go look for something unique that I can make out of that, and so. Oftentimes in their sidebar, they have a little video playing. And one of the things that always catches my attention is they ask 50 people to dice an onion. And the range of people they get are some people that have never done that before. And they lay out on the bench in front of them when they're filming it, all kinds of different tools, from knives to choppers to all kinds of weird stuff. And if you've never done it before, it's just amazing how people try, and it's funny. And then there's people that are competent at it and they get it close enough, and then they have a chef or somebody that really knows what they're doing, and a good number of people they do it say, well, I do this all the time, this is just basic stuff, and chop and they're done. They got a nice diced onion. But you're exactly right, but they throw some people into that scenario, and they have all kinds of tools laying out in front of them, some professional grade, some novelty kitchen gadgets from some flea market somewhere or whatever. And even knowing how they work doesn't really make you good at doing that task. But there's tons and tons of books out there that list, for a flow chart, you use squares for this and make it look a little like a cylinder if it's a place you're storing data. And then there's a triangle. Triangles are always decisions for some reason. I don't know why octagons aren't used for decisions, but that
octagons are reserved for stops because they look like a stop sign.
Yeah, is that universal? Anyway,
as far as I'm aware.
Okay. Well, somebody, they come up with, and they name all this stuff where if you're doing a fault tree, and this is, here's an AND gate and a NOR gate. And if you get the advanced class, you'll get a NOR gate, and other fancy gates that you can put in there. And I'm like, okay, how does this all work? How do I put this together? But more importantly is, when and why would I ever use this? What's the motivation that said this is the right screwdriver to use? I need a bandsaw with a thin blade that's got a tight turning radius. That's a different level of understanding of the tool. But I think it's equally important to know, well, what's the circumstance that I need to go look for a particular tool. I had a client a couple of weeks ago that asked us, says, hey, we need to do a long-term storage life. And is it okay if I just use the Arrhenius equation and use the, 10 degrees cuts the time in half? And can I use that in reverse and just apply it and to this data sheet thing that we got and say it's going to last as long enough for us? Or do we need to run the test? And okay. And they admitted they didn't know much about the Arrhenius equation or accelerated testing or all this other stuff. And it's like, okay, let me lay out some other things you need to consider here. How important is it that you know a real answer to this? What are you trying to do? Why is this question coming up? What's the context here? And it was back to what you said is early on. It was like, well, are you building a table or a chair? All right. Well, then that narrows down the selection of your options dramatically. And yeah, maybe just a rough guess is all you need. That's fine. But if you really need to know the answer, well, then it's a detailed accelerated test study, basically.
Well, going back to the power tool analogy, it's like, it's like someone who buys a Ryobi tool or a DeWalt tool or what have you, writing a letter of complaint back to Ryobi or DeWalt or whoever's manufacturing the tool and complaining that the manual doesn't tell them when and how to use the sander or the bandsaw or the circular saw.
Yep.
Now, Ryobi, well, the manufacturer would almost certainly ignore that letter, but let's just say that they felt particularly charitable on a particular day and said, well, what are you trying to build? And then the customer says, well, we don't know yet. What are we trying to build? And then that's not that far removed from how many reliability engineering conversations go.
Oh, we need to do an FMEA, and then we're going to do HALT, and then we're going to do some testing. And we're going to line out all of our testing right now and then on Tuesday we're doing an FMEA. Well, what are we doing it on? I don't know. We'll figure it out then.
Yep.
It depends on who's in the room.
Yep.
But we just need to do one so we can tick the box and say we did it. There's too many of them that just throw a bunch of. The other scenario, and Carl talks about this on occasion, is you open up all these books and manuals, and there's all these cool looking tools in there. You get all the shiny ones out on your bench, and you say, all right, today we're going to use a bandsaw. Tomorrow we're going to use a table saw, and let's try the circular saw, see what that does for us. And they try every tool in the book, every method in the book, and now you've got a lab full of samples that are all being exercised and jumping up and down and moving left and right, and people are measuring this, that, and the other thing, and you learn nothing. You're busy as all get out. You're really, really active. You might get something that's combination chair workbench out of it, but that's probably not what you were aiming for.
No, it's more common than perhaps our listeners would think. But maybe our listeners can really relate to that scenario where people confuse effort with outcomes.
Yep. Yeah. Now you should trademark that. It's
trademark what? Confusing effort with outcomes.
Yeah. You say that a lot. We got to use that.
I mean, it makes you feel good if you don't know what to do. You're usually doing something.
That's right. It's like, I'm going to go make sawdust. Well, what are you working on? Oh, I'm just making sawdust.
Right.
Use that analogy when we're it.
The master craftsman over there who made this beautiful kitchen cabinet, he created a lot of sawdust. So therefore, if I create a lot of sawdust,
I'll end up with a cabinet. Yeah.
Right.
Yeah.
Again, that is not that far removed from many.
Well, the part of it is what's the right tool, right? And I think,
right.
And one of the hazards I see in getting really good at using a bandsaw is that you only look for projects that use a bandsaw.
Yeah.
And you get really, really good at it. And then there's room in reliability engineering to be really good at, say, accelerated testing. And that's your depth of knowledge and expertise can be in that area. Yet I think the true master is the one that says, this is not a case for an accelerated test. Let's go use, some other tool to solve this particular problem or provide this information or do whatever. How about we actually go talk to customers to see what environment they're using before we make sure it works at sub-freezing levels? Because I think most of our clients are in office buildings in the Amazon. I don't think their air conditioner takes them to sub-freezing.
Nope.
So the true master is the one that says, is this the right tool? Is this the appropriate approach to get to our objective? And as opposed to getting good enough with it that now I'm going to just use it all the time because I need more practice. I think that's a tipping point of understanding all these different reliability tools, is not excluding them because you're not familiar with them, or you just want to practice on doing FMEA, so you do it all the time. And it's may not be the right thing to do. But there's a whole nother half to this though, Chris.
What's that?
The communicating part is, if you say we need to use a bandsaw and you can't explain why we need to use a bandsaw and what benefit this bandsaw has versus all the other shiny tools in the kit, and the team has never ever seen a bandsaw before, now you're going to be using the bandsaw over in the corner all by yourself and nobody cares. And I'm thinking of if you make a recommendation to do halt on a project, and you just say, trust me, do halt, you'll save a lot of money. And they're going to look at you like, what? What are you talking about? How does this work? And so being able to communicate well, to listen to where are they? What do they need to know? Is it some training on halt, and what's the concept? How's it tie to your business objectives? How does this actually lead to generating a valuable outcome at all? What do you mean you're going to go and break it with overstress? What's the point in that? If you're not able to communicate what this tool is capable of doing and what the potential benefits are and how does that relate to the problem that we're trying to solve, you can pull that tool out and show it to them all day long, but they're going to like, so the communication part, I think, is equally critical as being good at using the various tools.
Right. And I think, and with reliability tools, their utility is often hidden. I mean, you can, a tradesperson can see how a circular saw works once. Mm-hmm. And if that's the first time they've seen that, they will instantly know that that is more efficient than using a handsaw because they can see it.
Right.
It's intuitive. You can just see, oh, okay, that just went through that piece of wood in less than 10 seconds. That would have taken me a good 10 minutes to cut by hand. Wouldn't have been as straight or as good a cut, et cetera, et cetera, et cetera. You can see a circular saw and say, oh, that's the way to go.
Yep.
Not so with halt. I mean, it's not necessarily intuitive. I mean, once you understand what halt does, and then you go, that it should make a lot of sense when it's done well. It makes a ton of sense. But unless people can link how halt makes their world more valuable, the same way that tradesperson can just instantly see that a circular saw saves time and has creates a better cut, it's not going to be used. And the other problem too is that some of us have seen, let's just say 6 degree of freedom CNC machines, which you can put a lump of metal inside in the chamber and get a CAD program to design a wonderfully complex shape, which will then this CNC machine will automatically mill for you with various tools. It automatically selects and et cetera, et cetera. We have this little robotic arm just moving around, taking metal away, taking metal away, taking metal away. And it is a cool thing to watch. I don't care who you are. It's just fascinating watching those machines do that.
Yep.
However, if that piece of metal that it produces could perhaps not only just as easily, but more effectively be produced by a bending machine, then
it's a right angle bracket to hold the shelf up.
Right.
And you use a block of metal to cut it away to make an angle.
It looks cool, but unfortunately, the CNC machine costs hundreds of thousands of dollars. You need someone to sit down on a software package to design your right angle bracket. you go through lots of wasted metal because it's just carving, or turning your block of metal into 99% filings,
Yep.
et cetera, et cetera, et cetera. But it's easily the coolest tool you have in your shop. A lot of times, reliability engineering companies and organizations go straight to that 6 degree of freedom CNC machine, and all they need to do is go to the bender. And by the way, the bender, in addition to it not going through nearly as much metal, because it essentially it allows you to align grain structures, is probably a better product, stronger product as a result.
Yeah. Well, the other extreme, I've seen plenty of reliability shops set up, and they only do parts count prediction for you.
Right.
You know, like, okay, just because you've got that software doesn't mean you need to impose it on everybody for all kinds of reasons. And, well, I've got a Weibull plotting machine, so I'm going to put everything through that. I'm going to measure, I don't care what it is, I'm going to measure it 20 times so I can plot it on a Weibull plot. I will create a straight line.
Yep.
Okay, great. Why?
Good for you.
Yeah. Have a good day. Not happening here. But I think it's the communication part, being able to help people understand what it is this tool does and how does it tie into business. And that comes in the form of team meetings and discussions and conversations and asking questions and understanding what other people's motivations are. We're trying to create a chair here. I actually had one company I was working with, they made radiation therapy equipment for treating cancer. And they says, this is tough. Come on, give us a break. We're trying to cure cancer here, and we're talking about hypothesis testing. And, they were asking a bunch of questions about it and trying to understand it. And it was all good. But then they said, oh, give me a break. We're trying to cure cancer here, which I think was one of their standard pushbacks for anything.
Right.
But anyway, it's being able to influence other people involves communicating skills. It's not the results of your HALT test, because I'm sure there's more than myself in this audience that have taken perfectly good HALT results to a team that was told they had to do HALT. So it got shipped off to a lab, and somebody wrote a beautiful report of all these cool failure mechanisms they found, and they looked at it and says, well, of course it broke. You overstressed it. What's the point of that? And at that point, you're deep in the hole trying to catch up to help them understand what in the world was going on. So the communicating part starts before you select the tool. And then it goes into, well, this is why we're selecting this tool. This is why we're going after this approach. Here's the and that's all in writing and talking and discussions and building consensus and building understanding. And that's all communication skills. And that's not in the handbook of reliability methods. And that's been a revelation over the years, of the number of people that just are happy just write the report and send it off. And I've done my job. And I thought, well, you haven't. It's not there yet.
Well, you talked about communication, and you talked about, workshops and work groups where people share ideas about how you use the tool. Might I suggest that instead of having a workshop on how tools are used, have workshops on specific problems. So, for example, how do we solve this problem? Oh, well, sometimes a Weibull plot can help, but sometimes this sort of test over here can help. So as opposed to focusing on the tool, you focus on the problem, which goes back to the decision or the outcome of whatever it is you're trying to achieve. And that can often just simply have quite a big positive effect on mindset, as opposed to trying to work at how we can use a bandsaw. Start talking about what we want the wood to look like. Oh, so if you want the wood to look like this, a bandsaw is really good. If you want it to look like this, then maybe you need a drop saw or whatever it is.
Yeah, or if you need to cut a curve in a piece of wood, then a bandsaw is a great tool. But so is a jigsaw, and so is rough cutting it and then using sanding.
Right.
There's multiple approaches to that, and each of them have pros and cons and benefits and timing and the quality of the output and everything else. But it's a great idea. Start with what you're trying to achieve, and then say, all right, here's some options, which pulls on your ability to know what's in the wood shop, what tools you have, or as a reliability engineer, what options are available. And then go through those with your team to say, all right, if that's the objective, here's a couple of options we have. Which one can we do with our budget, with our understanding, with our equipment, with the number of samples we have? Which one will get us to the results we're looking for so we can move forward? That's a great way to put it.
And you look at the jigsaw and the bandsaw, that's a perfect example of how two tools, which technically do roughly the same thing. I know there's some master craftsmen out there who will be vomiting with that very high level generalization. But essentially they do roughly the same thing. But why would you use a bandsaw over a jigsaw? Well, firstly, if you can't take your piece to the workshop, if you have a big bit of wood and it needs to stay wherever that big bit of wood is, then a jigsaw is nice and portable, and you can do that. If you're able to, if you want a really perfect radial curve, then a jigsaw allows you to, in some cases, physically pivot the wood on an adjoining work table. So you just turn this wood, and you've got a beautiful radius cut automatically happening. Whereas a jigsaw is not quite as easy. It's not quite as easy to do that. So even tools which, from an outsider's perspective, do, for all intents and purposes, identical things, well, it's still not cut and dry which one you're going to use. Bandsaws are also much better at that. Each saw element, the band itself, it lasts a lot longer, so it's much better at sort of high volume cutting. Whereas a jigsaw, the saw itself is only secured at one end, and it will break a lot quicker. So
and bend, yeah. Even just bending, then your saw has a mind of its own which direction it wants to go.
Right. Well, bandsaws don't have that. They're designed in a way where physics prevents that from happening. So the two tools which do the same thing, but they are so better suited to different scenarios depending on what that scenario is. So you just can't simply complain, the bandsaw manual doesn't tell me if I should be using it at 10 o'clock on a Tuesday. What are you trying to achieve? Those workshops, as opposed to going through tools, say, okay, what reliability problem can we achieve? Sometimes a Weibull plot can help. Sometimes a fault tree analysis can help. Sometimes just
a histogram is all you need.
Right.
Move on. Oh, and I think this episode probably come out after your next webinar, but it's on, what do you see in a Weibull plot? So
right.
I'm looking forward to that one. See what kind of amazing graphics you come up with, as usual. But that might be a whole, a way to frame a bunch of episodes or webinars is, here's the problem. What are the options here? How do we move forward to solve this thing? How do we narrow down? Do we use a jigsaw or a bandsaw to once again use our workshop analogy?
Right.
Yeah. No, I think that's an idea. So anyway, let's wrap it up there. If you're listening to this and you're wondering why we're talking about a bandsaw, well, sorry about that. But the idea of selecting the tools to fit the job should be universal. And if that's a struggle, if you're not catching what we're doing here, or if you can want to reinforce that, let us know. Head over to accendoreliability.com/go/SOR, or you can get a hold of Chris or I on via LinkedIn, or the other hosts of the show via LinkedIn, or on our About pages on Accendo. So lots of ways for you to get in touch with us. So tell us your tool stories and whether or not you liked our running analogy here, or if that's the right word, or using woodshop tools. We'd love to hear from you either way. So I think with that, Chris, I think we'll turn off the bandsaw and go work on something else for a while.
Absolutely.
All right. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.